Hi, this is Joe from the Math Perimeter. In this video, we will evaluate the improper integrals. The integral from minus infinity to 0 of e to the x dx. The integral from 1 to infinity of 1 over x squared dx. And the integral from minus infinity to infinity of 1 over x squared plus 1 dx. First, we evaluate the integral from minus infinity to 0 of e to the x dx. Rewriting as a limit gives the limit as a approaches negative infinity of the integral from a to 0 of e to the x dx. Integrating, we obtain the limit as a approaches negative infinity of e to the x from a to 0. Applying the fundamental theorem of calculus, we obtain the limit as a approaches negative infinity of e to the 0 minus e to the a. Evaluating e to the 0, we obtain the limit as a approaches negative infinity of 1 minus e to the a. Applying the sum rule gives the limit as a approaches negative infinity of 1 minus the limit as a approaches negative infinity of e to the a. Taking the limits, we get 1 minus 0. Subtracting, we arrive at a final answer of 1. Next, we evaluate the integral from 1 to infinity of 1 over x squared dx. Rewriting as a limit, we obtain the limit as b approaches infinity of the integral from 1 to b of 1 over x squared dx. Rewriting the integrand in terms of negative exponents gives the limit as b approaches infinity of the integral from 1 to b of x to the negative 2 dx. Integrating, we obtain the limit as b approaches infinity of negative x to the negative 1 from 1 to b. In terms of positive exponents, this is the limit as b approaches infinity of negative 1 over x from 1 to b. Next, we apply the fundamental theorem of calculus to get the limit as b approaches infinity of minus 1 over b plus 1 over 1. Simplifying the second term gives the limit as b approaches infinity of minus 1 over b plus 1. Applying the sum rule gives the limit as b approaches infinity of minus 1 over b plus the limit as b approaches infinity of 1. Using the constant multiple rule, we obtain minus the limit as b approaches infinity of 1 over b plus the limit as b approaches infinity of 1. Evaluating the limits, we obtain minus 0 plus 1. Multiplying gives 0 plus 1. Adding, we arrive at a final answer of 1. Lastly, we evaluate the integral from minus infinity to infinity of 1 over x squared plus 1 dx. This is equivalent to the integral from minus infinity to 0 of 1 over x squared plus 1 dx plus the integral from 0 to infinity of 1 over x squared plus 1 dx. Rewriting the integrals as limits, we obtain the limit as a approaches negative infinity of the integral from a to 0 of 1 over x squared plus 1 dx plus the limit as b approaches infinity of the integral from 0 to b of 1 over x squared plus 1 dx. Integrating, we obtain the limit as a approaches negative infinity of arctangent of x from a to 0 plus the limit as b approaches infinity of arctangent of x from 0 to b. Applying the fundamental theorem of calculus gives the limit as a approaches negative infinity of arctangent of 0 minus arctangent of a plus the limit as b approaches infinity of arctangent of b minus arctangent of 0. Evaluating arctangent of 0, we get the limit as a approaches negative infinity of 0 minus arctangent of a plus the limit as b approaches infinity of arctangent of b minus 0. Subtracting, we obtain The limit as a approaches negative infinity of minus arctangent of a plus the limit as b approaches infinity of arctangent of b. Applying the constant multiple rule, we get minus limit as a approaches negative infinity of arctangent of a plus the limit as b approaches infinity of arctangent of b. Evaluating the limits, we obtain minus negative pi over 2 plus pi over 2. Multiplying, we get pi over 2 plus pi over 2. Adding then gives 2 pi over 2. Dividing, we arrive at a final answer of pi. Thank you for watching. I hope you enjoyed the video. Please like and subscribe. Thank you. See you next time.